we will pick up today with assuming that you've already read the chapter about looping, and I see many of you've taken the quiz already, so that confirms reading the chapter, I hope, and watching the lecture on the full treatment of looping. So today I just wanted to do show and tell, like I said, and go through some of this stuff. So we're talking about repetition. We have work that we need to do multiple times. So I created a simple little main function to give me a place to work here. Do some loop stuff. So let's say that I want to print the numbers from 1 to 10. So one of the things that I always try to emphasize as you're learning about repetition, I do the same thing in Python, same thing in C#, same thing in Java. This is just the pattern that I like to point out to everybody. All loops consist of 3 main components. The first is setting the initial condition. So we declare a variable called index and set it to 0. So that's setting the initial loop condition to 0. Then we have the loop syntax, so the while. So what we're doing here is basically checking the loop index. And then somewhere inside the loop, we need to modify the loop condition. So I would say this is a complete loop, although it's trivial, it doesn't do anything, right? But it has all the required components. Sets the initial condition, tests the condition, and updates the condition. Obviously, if we forgot to update the condition, now we've got an infinite loop. Yeah, while statement is empty body. Yes, I know that. Variable index is not updated inside loop. So thank you, IntelliJ, for warning me of these situations, but yes, I know that. So back to having a functioning loop. If I run it, it should do what I want to do, which is nothing, but it did nothing 10 times. I could step through it to prove it, but I assume that you guys trust me. So I run it again, and now it gives me the number 0 through 9. So it's not exactly what my specifications called for. I want the numbers 1 through 10. So I got a couple of ways to modify this off by 1 error, right? To correct this off by 1 error. That's what we normally call this kind of error when we're indexing our loop one way and we're using the value and expecting it to be another in practice. So I could just say, don't print index plus 1. Now I get 1 through 10 correctly. Okay, but that's a little awkward. I don't prefer the pattern of doing math inside print statements like that. If I was going to do it that way, I'd probably prefer to say, something like that. And then I would change this to print. But a better way to do this would be to control my loop better, start the index at 1. Now if I run it, now it correctly starts at 1, but it doesn't finish. I still have an off by 1 error. It's just the symptoms have changed a little bit. You might call this a premature conclusion error. So what's the obvious problem here? How would you correct this? Yeah?
You put less than equals at the...
Yeah, that's a great suggestion. We change from less than to less than or equals. Let's verify that that works. Yep, perfect. Goes 1 through 10 now. Or another way we could do it is change that to 1 through 11. Right? I'll run that again and verify, yes, we correctly get 1 through 10 again. That may seem a little odd, right? So I'm using, 1 through 10 in my problem description. You'd like to see the values 1 and the value 10 somewhere in the expressions that are involved in the problem solution, right? So this feels a little bit more dirty than just making it less than or equal to. But you guys see where we're going with this. So maybe less than or equal to 10 looks better. And boom, there we go. So we successfully printed the values 1 through 10. This is what we would call definite repetition as opposed to indefinite repetition. It's definite, and I use this definition carefully. The reason why we call it definite repetition is when the loop starts to execute. We know how many times we expect this loop to repeat, how many iterations will occur, right? 10. It's not a surprise. We expect this to repeat 10 times. That makes this definite repetition. Okay, what if, let's say, I have to do a scanner, right? Let's get an integer. And instead of stopping at 10, we'll stop at upper limit. So let's see what that does. Wow. Okay, it doesn't appear it's doing anything, but it's probably just sitting there waiting since I didn't put a prompt out. So let me say 17, enter. And then it printed the values 1 through 17, as we could have predicted. So is this definite or indefinite repetition? You've only got one of two choices, so you got a 50-50 chance of being right. What do you think it is? Definite or indefinite? Of course, it's a trick question. You might think I'm expecting you to say indefinite because now the user enters the number of times we're going to repeat. But no, this is still definite repetition because when the loop begins, upper limit is set. So at that point, we know exactly how many times it's going to iterate. 17 times, right? Because that's what the user entered. So we're not trying to be too over-restrictive with the definition of definite and indefinite. It's just a pattern. We're describing this kind of a pattern where we're comparing an index that we're going to increment against an upper limit of some kind, and that's how many times we expect to loop, and we construct it that way. That's how we can tell. If it does 16, if it does 18, we know we've gotten off by 1 error. It goes 0 through 16 instead of 1 through 17, we know we've gotten off by 1 error somewhere. Okay, so it's just, definite repetition. We should be able to predict and validate that it executed the correct number of times. It's definite repetition. Which begs the question, okay, well, what does indefinite repetition look like? So let's do one of those. So instead of upper limit, let me get rid of this stuff. Let me just do let's give it a prompt this time. And I'm going to use a while loop again. Sure, this thing is just too smart. It takes all the fun out of programming. So once again, we have a functional loop. We've set the initial condition, which is here this time. We're testing the condition. So as long as the word yes is entered, this loop will keep going. And within the loop, we've modified the loop condition by asking them to enter something again. I guess I should put my prompt down here too, otherwise it'll look confusing again. So once again, it's a weird loop because it doesn't really do any work. It just repeats. But if I run this, process again, yes, no, yes, process again, yes, no, process again, yes, no, and I could answer anything other than yes, and it'll stop looping. So it quit. It doesn't have to be, this is a pattern for creating a loop like this. You prompt them for what you want them to do if they want to keep repeating, and if they have to very strictly match that, or you stop repeating. That's pretty typical. In this case, we used an equals ignore case, so they could do uppercase combinations of yes, but it always has to be a combination of yes. We could do something like contains yes also. We could get fancy with it, whatever we want to do. As long as it contains the word yes. Then it'll keep going. And anything other than a string that contains yes will cause it to exit. So, is this definite or indefinite repetition? This is not a trick question. It's indefinite, right? Because when the loop starts, we don't know how many times it's going to process. We don't know, there's not a basis by which we can try to identify an off by one error. You might do things like every time they say, yes, we want to keep going, we add one to count. And then at the end, and then we can see if that works. Yes, 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 no. Says you've processed 3 times. Seems reasonable. There's lots of obvious problems that you can encounter when constructing loops like this. You can put the work in the wrong place. Is this going to affect what I print out at the end? What would you predict that I'm going to get for count when I run this one, if I use the same inputs? Yes 3 times and then no once. Come on, help me out here. Don't make me answer all the questions. How many people say it'll do it 2 times? How many people think 3 times? How many people 4 times? Yeah, in this case, it didn't really matter whether I do the work before or after, or does it? I think it's still gonna say 3, but it's gonna look weird. So if I run this, process again, yes. But it's gonna ask me process again, yes, before it updates count. But eventually, it'll get around to updating count so that by the time it exits the loop, it still says 3, right? So in this case, it didn't make any difference. But let's put that back where what feels right. And let's say we okay, so this is doing a little bit more. So let's say yes, 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 no. And you can say it did iteration 1, iteration 2, iteration 3. But if I moved this down, yes, iteration 0. Well, okay, I messed up that time. I said yes 4 times, so that was my fault. But my only point here was that, you know, it said 0, it would have said 0, 1, and 2 instead of 1, 2, and 3. So again, we have to be careful where we're incrementing this relative to what work we're doing in here, or we could end up with additional off by 1 errors. And that's my only point. It matters the order that you do this stuff. But as far as our basic loop goes, all that count stuff has nothing to do with the mechanics of the loop. That is relative to the work that we're doing inside the loop. And another one of the points that I make in going over the full chapter is that there's stuff we do before we start looping. You know, if I have some kind of a welcome message. You know, there's stuff that I can do before I have to do any kind of repetition. Has nothing to do with the loop. There's stuff that I can do inside the loop. And then there's stuff that I can do at the end. This is all pre-work, this is all in-loop work, this is all post-loop work. You know, the life goes on after your loop, but that does not take away from the fact that you have setting the initial condition, testing the condition, and then modifying the condition inside the loop in order to make the mechanics of the loop work. Okay? I feel like I've beaten that to death. So I'm going to throw a little bit of a spin on this. Let me clean up some of the stuff just to get back to the basic mechanics of the loop. So this works, we would say, right? So there's another pattern another mechanic of constructing loops in Java that we have available that, you also have this in C++ and C#, but you don't have it in Python, for example, which is what I call the do ... while. So instead of having this while condition here at the start, we just say do. So, hey, I've got a block of code and I'm going to do stuff. And then at the end, I'm going to put the while condition. So this is a post-loop checking of the condition. So we've already done an iteration of the loop before we check to see if we need to be looping or not. It's just as valid, but one thing this allows us to do, like it's a little bit awkward if, like with that other example the other modification that I did, I would probably write this one more like this. I don't know. Come on. So to me, it's a little weird the first time through the loop to say, do you want to process again? Because we haven't done anything, we haven't processed yet. So I'm going to say, I'm going to hard code this to yes, or how about we'll make it very clear. So keep going means is set to I don't know yet whether I'm supposed to loop again or not. I'm setting the initial condition, I guess, but I'm setting it to something uninitialized basically. And I'm doing this on purpose to be clear to you guys, like self-documenting code. I could have just as easily set it to blank or nothing or whatever, all Z's. But the point is, it's set to some meaningless value. And my intention is, I'm going to start looping. I'm going to do some work, the first iteration through the loop. And then I'm going to set my loop condition. And then I'm going to check it to see whether I continue looping. Seems a little odd after we just went through a nice, clean-looking pattern, right? I wouldn't say this pattern is used as commonly, but it is used, so it's a good thing to have in your toolbox. So you're doing the work before you're checking to see if there's work to do, or if there's an iteration to do. I can do the same thing with the numeric. Any questions about this one before I erase it and go on to the numeric? Okay. So if I say int index equals 0, do while index is less than 10, and inside here I say index plus plus. Let's say okay, if I run this, a little different output, but it prints 0 through 9. just like our very first one did with putting the while at the beginning of the loop. We can make this work just like the other one. If I start at 1 instead of 0, my first iteration will be 1, but I've got an off by 1 error at the end. I can say index is less than or equal to 10. It goes 1 through 10. So I have all the same power, all the same control that I had with the variation where I'm checking the loop condition at the beginning of the loop. It's just different. Okay, so that's while and its variance. So now we get to what we call a counted do, or what you'll commonly hear referred to as a for loop. And the great thing about a for loop is it's shorthand for all the while stuff that we've been doing before, where it consists of all the same parts: set the initial condition, check the condition, modify the condition, but it lets you do it in a shorthand form. Okay? So it's got 3 parts in this variation: set the initial condition, the condition that you want to test, and how you want to modify the condition. Now you can do whatever you want here. You guys okay back there? You guys need help?
No, I got it. Just trying to figure out the issue. So.
Okay, can you not need help quieter? Because you're distracting me. Huh, look at that. Isn't that funny? So let's see what this one does. So that's a cool thing about the for loop, is that you're not restricted to one index variable. You can define multiple variables and set the multiple variables to a start condition. I only still left checking one of the variables for the end condition, and then you can modify multiple things for the third portion of this. Pretty cool, huh? You can do this in both Java and C++. I don't remember if it works in C# or not, but you can try it and see if you feel like it. But I mean, I could do all of that in one line of code is the great thing about it. But the main point I want to make about this is all the same mechanics are occurring as with the basic while loop. And the other thing that I try to get everybody to remember, write it on your arm if you need to, all for loops can be expressed as a while loop, but not all while loops can be expressed as a for loop. The for loop is a special case. Of all the possible set of all loops that you could build, some of them you can use a for loop to do the same thing, but with fewer lines of code. That's how I would describe the for loop, okay? There's another variation of the for loop. We haven't gone over collections or anything like that, but essentially, let's say we've got a collection of items. If we've got an item class and we've got a collection of them, we can iterate a collection very easily and succinctly The great thing about this is we don't need to know or find out how many items there are in the items collection, because the for loop implementation will figure that out for us, which prevents any kind of off by one errors in the mechanics of the loop. It makes it a little bit awkward if we want to say something like, right, if we want to say processing item number 1, processing item number 2, processing item number 3, that's a little awkward. I can still do it, but I have to do it externally. Processing item I can do that, but then I also have to, and it's like, well, wait a minute, if I'm adding all this logic in here to add one, define a variable, add one to it, and then include it in my work that I'm doing, then what did this save me? I might as well go back to saying, just do a counted loop, right? So use these things judiciously. They're not a one-size-fits-all kind of thing. They don't, just because we learned a new syntax and it's more advanced, doesn't mean that it applies everywhere. Every problem that you see now, you should expect to be able to use a for loop of some kind for it, or which kind of for loop that you're going to use. No, I would keep it in my head that I can write any repetition that I need to write in my program using the basic while structure. Set the initial condition, test the condition, update the condition. And then if it happens to be a problem where the for loop syntax applies, great. That's just gravy. It reduces the number of lines of code and makes it look a little bit cleaner. Great, I'll use it. But use the right tool for the job, I guess is my point. We get into other variations of this, just to point it out. We call these nested loops. We can do definite inside of indefinite, indefinite inside of definite, definite inside of definite, all the variations. We can do any kind of while loop inside of any other kind of loop. We can take any block of working code and wrap it inside of a loop and do it multiple times. It's just parts is parts. So if I wanted to do, I guess the easy thing would be like the multiplication tables. That's one of the classic problems we do learning programming in Python, right? So if I wanted to write the multiplication tables from 1 to 10, okay, I'll do 5. And inside here, I'm going to print inner times outer. It's always annoying that Java makes you type that system.out in front of every print statement, but it is what it is. And then I'm going to add a tab character just to make it format prettier. Okay, so if I run this, I get the classic 1 times 1 is 1, 1 times 2 is 2, 1 times 3, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, just the normal multiplication tables. But all I did was I nested one for loop inside another for loop. Better way to look at this maybe is your outer loop is always your rows and your inner loop is always your columns. So that might be better variable names to use instead of outer and inner. Outer is obviously the outer loop, inner is the inner loop, but what they represent is rows and columns in this example, so that might be better variable names here. Any questions about that one? So that's nesting of loops. And then there are other forms of repetition just for completeness. Classic problem to illustrate basic recursion is the Fibonacci numbers. I want to get like a number. Okay, this pattern that it threw in here is kind of interesting. It didn't do this the last time, but we ran into this when I was looking at a problem with somebody's code last time with getting input. So I print this, it's using a print line, so it prints enter number colon space and does a carriage return. It's probably not what I wanted in this case. I probably want print. So it stays on the same line. It doesn't do the carriage return down to the, so my cursor is sitting out there after the space, after the colon. Then my scanner, if I say next int, what the scanner does is it's set up to watch, so system.in is what we call an input stream. It's a stream of data that comes in, and it is kind of event driven. Whenever a character, a key is pressed, a character gets put on the stream, and an event gets thrown that says, hey, I just had a new character. So people that are consuming that input stream, you're watching and you've got a pointer at a certain point in the stream, and you can decide when and how you want to consume the characters that follow. You can't really go upstream. Once you've consumed a character and processed it, it's gone. But you can decide how you want to take the stuff that's next. So when we say next int, the scanner, that function is written to say, from the point you're pointing at in the stream, look for characters that would be valid legal integer characters next in the stream. And it's either going to find some or it doesn't. If it finds some illegal characters, then it's going to throw an exception and say, oh, sorry, I can't process this data that you gave me. It pulled the data off the stream, but then what it did with it after that to process it wasn't good. But let's say it works. So let's say you enter 1, 2, 3. So it pulls the 1, 2, 3 off of there, but it didn't pull the carriage return. If you said 1, 2, 3, enter, it pulled the 1, 2, 3 off, but it left the enter sitting there. So then if you come down here and say, next line, it's going to get the carriage return from the previous, when you entered the 1, 2, 3, not when you typed YES and hit enter. So that's just one thing to be careful for. You kind of need to say, say it like this. So I want to get a full line of text off the stream, the 1, 2, 3 plus the carriage return. And then you're going to pass it to integer parse int. And that's going to say, okay, I see the 1, 2, 3 and the carriage return in this string. I'm going to pull the integer part off of it and return that to number. And so you've eaten the carriage return off of the stream coming in. And so your next scanner.next line will get what comes after that. So that's just a little thing there. It only came up because of the autocomplete threw that in there, so I thought I would mention that. Any questions about that? Felt like I glossed over that pretty well, or pretty quickly, so sorry if that was confusing. But in any event, I've said enter a number, and you've got a number here. So what I'm going to do is print the Fibonacci of number. Of course, I don't have a function. Okay. So basic implementation quick for Fibonacci. And then here's where it gets interesting. Is if you're going to calculate the Fibonacci numbers, Fibonacci of 3 is the Fibonacci of 2 plus the Fibonacci of 1. The Fibonacci of 5 is the Fibonacci of 4 plus the Fibonacci of 3. So that's how you calculate it. And so it just keeps growing and growing and growing as the sum of the previous two numbers. Make sense? And I'm not trying to ask you to understand Fibonacci numbers or their context or their history or who this Fibonacci guy was, some Italian mathematician dude that liked to name things after himself, whatever. That's not my point. My point is, if you give this, if you pass this a value of 3, it's going to call itself twice. So in essence, the Fibonacci function got executed 3 times. You passed it 3, it got executed 3 times. If you pass it 4, actually, it might have gotten called 4 times. Because when you call it for 2, it also calls it for 1. Okay, so we called it for 1, it returned 1. We call it for 2, no, it just returns 1. So yeah, if you pass it 3, it's going to call this function 3 times total. Let's see if we can demonstrate that by pointing out something else. So I'm going to create inside my public class, I'm going to create a static integer. Does everybody remember what static is? You know, we've got our public static main. Static means that we only have one of them. We can have multiple instances of this class, but all of those instances are only going to share, they're all going to share one counter. And it's useful for situations just like this. So I can say, so before I call it, I'm going to say counter equals 0. I'm going to call Fibonacci. And then we'll print this to see how many times it it called it. Hopefully, if I implemented this correctly, we'll see what it does. So I run it, it says enter a number 5. So it says the function got called 9 times. There, it's all prettified now. So if I run it, I enter 5. Okay, the Fibonacci number of 5 is 5. I'm not sure if I believe that. But the function got called in the process 9 times. So I pass it 5. It called, so that's one call. So then it turns around and calls itself with 4 and 3. That's 2 more times, so now we're up to 3. When it gets called with 4, it calls 3 and 2, so that's 2 more times. And with 3, it calls it with 2 and 1, that's 2 more times, so we're up to 7. You see where I'm going here? And so it all adds up to, in total, it got called 9 times. I passed in 5 and it called itself 9 times. Another interesting thing about this problem is it expands so quickly that you can enter seemingly small numbers and calculate the amount of time it takes to process, and it'll never return in our lifetime. So feel free to play with that and see how beefy your computer is and how big of a number you can actually get it to return. So the Fibonacci sequence goes 1, 1, 2, 3, 5. So yeah, the 5th number is 5, so that seems to have worked. Let's do it with a bigger number. How about 12? So the Fibonacci number of 12 is 144, so that grew pretty quickly. And it got called 287 times in order to calculate that. Let's run it again. So we did 12. How about 23? I noticed a slight pause there, but a small number like 23, and it called it 57,000 plus times. So we're expanding pretty quickly there. How about 112? I hear my fan starting up down here. So there you go. That's Fibonacci numbers. And circling around, Fibonacci is a fun problem, a fun thing to play with, but this is considered another form of repetition referred to as recursion. You're recursively calling the same function within a call to that same function. Okay? In this case, we're calling it twice for each call, potentially. Okay? And I'll go ahead and stop this because I'm not sure. I don't want the Earth to explode before it finishes. So. But 112 is a seemingly small number. You'd think, oh yeah, maybe it'll take a few seconds. No, that's a lot of calculation. I think if I remember right, the math on that is whatever number you give it, it's processing like n factorial number of times, number of repetitions. inside there. So it expands pretty quickly. Okay, well, that's pretty much all I wanted to cover on demonstrating different ways that you can use loops. So we covered basic while loop. We covered do ... while, checking the condition at the end of the loop. We covered the basic counted repetition, which is just a for loop. We looked at the other form of the for loop where you're saying just for everyone, they call it a for each, but in Java they still use the keyword for. Other languages they use the keyword for each to designate it differently than the for keyword. But that's what they refer to it as. That was a for each pattern, for each item in the collection, do something. And then recursion. So fun stuff, little show and tell today. And we'll pick up